Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, have a good day. Let's introduce ourselves. We come from Omicron group. We will discuss and give some information about XPS or X-ray Photoelectron Spectroscopy. Pleasure us, my name is Dinar Wardhani and my friend is Fitri Hidayah. Anyways, this video are made by PowerPoint presentation. Okay, let's start into the slide information. As you can see in the slide and some figure, the first figure is the tools of X-ray photoelectron spectroscopy, as well known as XPS tools. And the second is about the graphic of example XPS surface spectrum of a polymer surface with element quantification. And the third is about the mechanism of XPS principle. And the last is about the diagram of X-ray photoelectron spectrometer. The X-ray source is incident on the sample, penetrating between 1 and 10 nanometer and generating the ejection of the electrons. Then the detector collects and identifies the electron binding energy to be translated and quantifies each element in atomic percent.
What is X-ray photoelectron spectroscopy? X-ray photoelectron spectroscopy (XPS) is one of the most well-known and widely used methods for the analysis of solid-state material. It measures the kinetic energy of emitted electron by photoelectric effect induced by X-ray illumination based on instant photoelectric effect. The energy of released core electron is one of the unique characteristics of the element to obtain information on the number of elements as well as the chemical bond in the system. XPS is a method of analyzing the photoelectron emitted by the photoelectric effect by irradiating an X-ray to a solid material. When the X-ray is irradiated to a solid sample, the energy of the photoelectron released from the specimen can be measured, and the bending energy of the electron at the core of a specific element in the material can be calculated.
For the next slide, what the characteristic of X-ray photoelectron spectroscopy? For the next slide, we will discuss about the characteristic of X-ray photoelectron spectroscopy. Let us to know the characteristic. Some of the main characteristics of XPS techniques are the following ones. The first is provide chemical bonding information related to all elements except hydrogen and helium. And the second is it is an expensive technique due to its highly sensitivity around of 0.018%. And the third is it works under high vacuum around 10 degree minus 8 to 10 degree minus 11 torr and low resolution. And the next is analysis area commonly is about 1 centimeter square. And the last characteristic is the estimated time of analysis can vary between half an hour and 8 hours depending on the nature of the sample.
What the principle of X-ray photoelectron spectroscopy? Basic principle. When energy is applied to the element, the excited electrons tend to depart from the nucleus and reach the point at which the bending energy between the nucleus and the electron becomes zero, and escape the restrained status from the nucleus to outside of the element. The energy level is defined as the Fermi level. Thus, the bending energy of the photoelectron is the energy difference between the Fermi level and the orbital of the originate electron. The bending energy is a unique characteristic of its element, as it is determined by the attraction between the nucleus and the electron, relying on the number of protons in the nucleus.
Let's continue about the basic principle of the XPS. Like surge with high energy are required to emit core electron of the key shell, having a very large binding energy by the photoelectric effect. Therefore, ALK or MGK are generally used as the X-ray like surge. The farther away the electron is from the atomic nucleus, the weaker the attraction between the two, and thus the binding energy decreases. On the contrary, as the distance between the electron and the atomic nucleus gets closer, the binding energy increases. Therefore, it is possible to distinguish a specific orbital of a specific element present in a sample by measuring binding energy. Since the binding energy of the specific orbital of each element varies slightly according to various chemical bonding states, it is also possible to analyze the binding state of a specific atomic orbital of specific element. The next slide, there is figure 1. For the XPS mechanism where the first electron is being excited from the key state to the vacuum or photoelectron emission. X-ray photoelectron spectroscopy makes us of soft X-ray or as opposed to an electron gun for EAS, often obtained from MGK or ALK. XPS spectrum consists of the number of electrons emitted against the binding energy. This describes which electrons are involved for each of the observed transitions.
What the application of X-ray photoelectron spectroscopy? Application: XPS is commonly used for gathering qualitative and quantitative elemental composition of a surface. The chemical stage element mapping with scanning XPS with a pure resolution. Surface sensitive 30 angstrom. Deep profiling of a surface region at 100 angstrom by angle dissolved XPS and deep profiling with argon sputtering. As XPS is applicable to insulator as well as conductor, the equation may also contain a term which reflects electrostatic charging of the specimen. This reduces the kinetic energy of the outgoing electron and is seen as a slight increase in the peak position 0 to 5 electron volume on a bending energy scale.
The next slide about what the advantage and disadvantage of X-ray photoelectron spectroscopy. Since the photoelectron generated inside a solid sample can be scattered by the interaction with other electrons in the system, the mean free path of the photoelectron is very short, at several nanometers. Thus, it is generally exploited for qualitative and quantitative analysis of the chemical structure and composition of the surface of the sample. It has the advantage that non-destructive analysis is possible due to its spectroscopic principle without damaging the sample. Therefore, the use of XPS is not limited as long as the interested sample is solid. Examples include catalyst, semiconductor, and surface-modified area such as thin films and coating. XPS is widely used in both surface science, that is, the gleaning of knowledge concerning the composition and crystallography of simple, or often single crystal, surface and the modification of said surface in a well-controlled manner, and surface analysis, the acquisition of analytical information concerning the outer surface layers material. As mentioned before, XPS is non-destructive techniques about to estimate the atomic percentage, hence quantitative analysis, per element and determine the chemical surface of several materials such as metals, metal alloys, polymers, ceramics, and organic.
XPS is known to be able to give information on the following: 1. The element present at the surface. 2. The chemical stage of this element. 3. The amount of each chemical stage of each element. 4. The spatial distribution of the material in 3 dimensions. 5. The material present as a thin film at the surface. 6. The thickness of the surface film. 7. The uniformity of the thickness of the surface film. 8. The uniformity of the chemical composition of the surface film. An additional advantage to XPS is that of the ability to detect small difference in the bending energy. Typical applications include the evaluation of adhesive failure, the identification of the chemical stage of the surface film, a passive oxide layer, the quantitative elemental deep profiling of insulator, the analysis of film contamination, the measurement of elemental composition of insulating material like polymer and glasses.
The next slide about why does X-ray photoelectron spectroscopy need UHV or ultra high vacuum? X-ray photoelectron spectroscopy need ultra-high vacuum. For the first factor is contaminant of surface. XPS is a surface-sensitive technique, and the contaminants will produce an XPS signal and lead to incorrect analysis of the surface of the composition. And the second is factor, the pressure of the vacuum system is around of 10 degree minus 9 torr, and the last is removing contamination. To remove the contamination of the sample surface is bombarded with argon ions. Heat and oxygen can be used to remove hydrocarbon.
This is a reference that support up our presentation material. Enough of the material that we convey, more or less we apologize. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.